Well, first of all, I want to welcome you to Accra if you haven't been here before. It's my first time. I'm Tony Wexler. I'm director of the Air Quality Research Center at UC Davis. Many of you have interacted with Sandra, who is our conference organizer, and so she works for me, okay? And I'm here, well, I was going to come here anyway to help her out, but I'm here without her because she's pregnant and her doctor said, "You're not going anywhere." So thank you for traveling as far as you did to get here. Can we get the next slide, please? So we had the promise of the mayor of Accra opening up the ceremonies here, but my understanding is that she will not be able to attend, which is the usual thing for people in that position. So we excuse her. We may get the general manager for Accra here at some point to give a few words, and so we may interrupt for him. But in the meantime, we will move on. Next slide, please. So I wanted to thank all the people who are here or who couldn't attend, but who helped organize this meeting, bringing together all the talks and the sessions, which sessions we need, and how to put them all together into a conference. You can see there's quite a long list of folks who have contributed their time to this meeting. So I'd like to thank them right now. So if you are here and are on this list, can you please stand up to be recognized? There's one in the back. Thank you. Next slide, please. So the meeting, these meetings could not happen without sponsorship. So some years ago, the Clean Air Fund in London approached us. We were already running these air sensor international conferences in California, and they saw us doing this, and it's pouring. You can hear that. There's a flood watch, I hear, so you may not be able to go very far when we leave the meeting. So anyway, the Clean Air Fund approached us a few years ago saying we would like you to run this meeting in other places besides California, especially developing countries. And so we're doing that now. So we ran one, well, I'll go to the schedule in a moment. But anyway, Clean Air Fund has been fantastic helping support these meetings, making them happen, and keeping the cost down or even zero, and helping people to be able to come to the meeting who can't afford it. We also like to thank AfriqAir and Clarity for their sponsorship. They have displays in the next room over if you'd like to go and see the products that they have that can be used to help you understand what the air quality situation is in your community. Next slide, please. Oh, that was too many. There you go. Thank you. So the history is we started this meeting in 2018. What happened was that the US EPA had a meeting called Next Gen, which was almost exactly the same mission as this series of meetings. That is to help get the whole new small sensor, inexpensive sensors of air quality moving forward. And then after a while, they stopped running the meeting. And so I called them up and I said, well, what's going on? Why aren't you running this meeting anymore? And they said, well, it got too big. And so they couldn't handle it. So I asked them, well, can we do it? They said, sure. So here we are. And so the first meeting was in 2018 in Oakland. And then we had this pandemic you may have heard of. And so we didn't have in-person meetings for a while. And so we had them online. We had online workshops where people were giving talks and leading discussions about this whole field. And then our second in-person meeting was in Pasadena, 2022. And we had one then in Bangalore last year. And here we are this year. Then there'll be one in Riverside, which is way at the bottom of the screen, and back in Riverside, California in 2024. And then we will be running conferences in other countries, but we haven't figured out the whole schedule yet. So you can see on your right-hand side of your screen a bunch of other statistics about this meeting. A lot of people are not here yet or were not able to attend, but did sign up, did register, and did submit talks and posters, and which are on the walls. So the posters are up, and we'll have time to view them. And of course, there are talks and panels throughout the day. There's also a journalist training also in the next room. Besides the exhibitors, there's also going to be a journalist training. I forget what it is on the schedule, but for the journalists who are here, it's a time for you to understand more about air quality and what this new sensor technology can provide to communities. Wow, it's coming down. Next slide, please. Okay, so our next session is going to be chaired by Subu and Mike Giordano. So why don't you come on up and take over? So we'll have a panelists discussing this whole issue here of evaluation of sensors, which some of you went on the tour, and so you saw some efforts in that direction. So thank you very much for attending. I'm glad to meet people that I've known and meet new people I didn't know before, and hope to do more of that as the conference progresses.
Great. Thanks, Tony. Yeah, let's give him a hand. Okay, so my name is Mike Giordano. Sensor evaluation and analysis, best approaches is basically what this session is going to be about. We have 4 panelists, Dr. Allison Hughes, probably saw today from the University of Ghana, Dr. Nuria Castell from NILU in Norway, Dr. Adrian Arif from Airparif in Paris, who will be joining us online. I think he's in the session right now. And Dr. Brigitte Language from Northwest University in South Africa. So how we're going to do this is each panelist will have a few minutes to talk about what they're doing in this sort of sensor evaluation and analysis space. And then we will open it up to more of sort of a roundtable and panel discussion. And we hope to have a lot of back and forth with the audience. So we'll start in this order. So Dr. Hughes, if you want to come up.
I think it's afternoon and it's a rainy one. So I say good afternoon to everyone. And thanks for the opportunity. Yeah, I have a few slides that I will use to just give a brief background about our work on sensor evaluation and analysis at the Department of Physics, University of Ghana. And I think a number of the participants were there this morning. We're happy to have you. And we had a nice time looking at our facilities. As mentioned by Mike, I'm Allison Hughes. I'm a senior lecturer in the Department of Physics, and I serve as a PI on the project, which is a joint project between University of Ghana and Afri-SET. AfriqAir. AfriqAir is based in the Carnegie Mellon University, Africa, in Kigali, Rwanda. And so this is a joint project that we have, and I am the facility manager. And yeah, next slide, please. So this first slide is just to show you what is happening with local sensors around the world. If you look at Africa, you see some local sensors. Most of those are local sensors, but the rest of Europe and America, they have a very dense network. And so local sensors are now taking a large interest in the local sensor manufacturers are taking a large interest in having some of these sensors put in Africa. And so you see that the network of sensors in Africa is quite low. And one of the reasons we decided to have this project is because sensors which tend to be called low cost are now being competitive with the reference grade monitor. Next slide, please. So the key objectives of Afri-SET, which is the Center for Evaluation and Training, the first thing we set out to do was to establish this evaluation and training center in the department, which many of you visited this morning. And I'll go a bit into why we did that. The next objective will be to facilitate capacity building and of students and air practitioners in Africa. And then we also want to promote the long-term sustainability and also replicate, a center like ours in other parts of Africa. We have done the establishment, but what went into this was we had a pilot project after we had this reference grade monitor put in to the department. There was a project with the Ghana EPA, and so we serve as host of one of the 2 reference monitors that were brought in by the World Bank for the country. And so after setting up that reference monitor, we did a pilot project with a couple of people, the US EPA, Columbia University, and Subu, and a number of persons. And so after that pilot, we thought that we could move on further to establish a center to do the evaluation, because the reports from those sensors that we brought was quite good. And we thought that this would help to look at how sensors perform, in the global south. We know in the global north that there's the South Coast AQMD, AQ-SPEC. We have NILU in Norway. We have the Airparif in France. So they have established these testing centers quite long ago. But in Africa, we thought that there's this gap, and we decided to approach Clean Air Fund, and we got the funding to set up this center. So the first thing we did was to develop our SOPs and had it vetted by those who had already been in the evaluation process, AQ-SPEC, NILU, and also Airparif, and went on to also build some MOUs with them, because these are giants and we want to stand on the shoulders of giants and learn a lot from where they have learned. And so this is our procedure. Our procedure is similar to what is done. You send 3, manufacturers send 3 sensors, and then these sensors are put up and co-located with our reference monitor. Here we have our T640, the Teledyne, and then we have a TIOM. And so our procedure is to evaluate them 6 weeks in the rainy period and 6 weeks in the dry period. And in our dry period or dry season, we have the Hamilton dust that impact, the city. So we want to see how they will also perform when we have this huge dust inflow that tend to cause, a lot of chaos and panic. For some of you who follow the news somewhere this year, there was a large inflow of the Hamilton dust, and Accra was said to be the most toxic city in the world. But that was it's a natural phenomenon, and we can't do much about it. But we have even had worse situations like that. So I believe the report came from a sensor, a local sensor, and then the journalists took it and it went all abroad. So when we contact check with our reference monitor, the EPA and the University of Ghana, we saw that the levels that they were quoting were much lower than what was on the reference grade monitor. So that is why we want to have local sensors calibrated. Sometimes they will give you such figures that are so high. Then we intend to also, we've built a website You can go to this year, Afri-SET.org, and you will see our website. What we intend to do is to host the data from all of these manufacturers, and with the reference data, we'll do the reports just like what is done at AQ-SPEC or NILU or Airparif, and then we'll do calibration protocol, and also we intend to also conduct training and put all these webinars there. Our website, we will have it in both French and English. And then we've targeted at least 10 different sensor manufacturers in our first year. I think we've surpassed that. We have now 11 and hopefully 12 very soon. And so at the site, each manufacturer sends 3 sensors. And so there we have about 33 sensors now. Next slide, please. Yeah, so I put this slide to just show you that sometime in November, when we took this picture, we just had our Teledyne there. Nothing, because we have finished our pilot project. And now, October, we see that the center is full with, the facility is full with all kinds of sensors from all around the world, all kinds of local sensors from around the world. Next slide. Yeah, so these are some of the sensors that we have on site. I remember many of you went there today. So we have a number of them. From Africa, we have the ECHO from Uganda, and then we have Sensor Africa from Kenya. Then the others from around the world, the US, Thailand, Poland, and the rest. Next slide. Yeah, so these are the list of manufacturers: AfriqAir, Sensor Africa, Air Gradient, Quantair, Air Quality Air, and the rest. Echo. So next slide. Yeah, so I showed you this earlier. This is just a blown up work. So this is the Teledyne, which is a reference grade monitor. And then we have the TIUM, also reference grade. We have these 2 gas monitors. We've not started with gases yet. We're doing only particulates and particulates in the ambient environment. We hope that maybe by first quarter or next quarter, 2024, we may start looking at the gases when we get our calibration gases to set up our gas monitors. The interesting thing here is that a lot of manufacturers are asking us to look at the gases because most of the sensors they have also have gases. And some are even asking that, what can they do? And we are open to work with them to put up a chamber and set it up and evaluate the gases also here. And then also they want us to also evaluate particulates also in the lab. So we are open and working with manufacturers because they want other stuff to be done. I mentioned earlier that we have 12 weeks, 6 weeks in the rainy period, 6 weeks in the dry period, but manufacturers are also asking us to keep the sensors there until we can look at how it degrades over time. Okay, so some manufacturers want that. Other wants us to then take the sensors after we have evaluated and find hosts for these sensors across the country. So we work with them and also spread these sensors around the country to have more idea on how the quality of air is in those. Next slide, please. Yeah, so these are some of the sensors. I know you saw all of these hanging up there. I won't waste time with it. Next slide. Yeah, next slide. Yeah, so these are just to show you what happens. We had ECHO, which is one of the manufacturers that has sent them their sensors. And so they sent down their staff, had a training with our staff to put up their sensors. So now they have built capacity. And I believe that next time, if they have sensors to come to Ghana, they don't need to travel from Uganda, but they can call on us and our staff to deploy them where they want to deploy them. And I think that is a plus for this center. Okay, Next slide. Yeah, so we said that we want to also build capacity of students and practitioners. So what we intend to do is to hold trainings, hands-on trainings for practitioners in West Africa each year. And these trainings will be more of looking at sensor installation, the usage and reference monitor, how to set up reference monitor, how to maintain them, and data, because we have a lot of data, how to handle the data analysis and modeling, and other value-added products, which, as I mentioned, other manufacturers are asking us to do. So we use machine learning and AI to also do more of the correction if they want us to go beyond the multilinear analysis. We also organize virtual trainings and webinars, and then also have materials that we'll develop and put there for people to go there on our website anytime and then educate themselves. We intend to work with a lot of stakeholder groups in the country and have them train, and also do some community engagement to be able to provide education on how air pollution affects the health of our citizens. Next slide. Yeah, so the next thing is to promote the long-term sustainability. We are grateful to the Clean Air Fund for funding this work, but they cannot fund it in perpetuity. So we will have to look for funds and partnership, and we have started. I see one of our research associates is here. We had him to visit Dr. Castell in Norway, and he went through a rigorous training with them. And we are now building a partnership. Hopefully next year we'll have a visit to Airparif in France, and also send one of them to AQ Specs in California, in the US. And then there are other things we hope to do to ensure that the center becomes viable and sustainable. We are thinking that other services that manufacturers need, we can render them, but for a cost. And we also intend to replicate this. Next slide, please. Yes, we want to have our work as a proof of concept, and once it works here, we believe that we should be able to encourage the setup in maybe East Africa or Southern Africa or any other parts of the world. So that's why we will interact with colleagues, bring them to also study and be trained. And by the end of the 3 years, we hope to start another center somewhere else in Africa. Next slide. Yeah, so this is our website. You can visit there and see what we have placed there. We have some publication that came out of this work, the pilot work, which was headed by Karima. She's sitting there, and the other team. Yeah, next slide. Yeah, so this is just showing the team that we work with. You saw the host, the coordinator from AfriqAir, Mike is there, myself, and then the rest of the team. Next slide. Yeah, so I want to acknowledge our partners, the Norwegian Institute of Air Research, NILU. We're very grateful for hosting one of our staff and for the fruitful discussions we've had so far, and looking forward to, building this relationship further. We also want to acknowledge Airparif we signed an MOU already with them, and hopefully we'll get our staff to do a visit and then continue the partnership. And then with AQ Spec, yes, we are building our relationship. Hopefully we will get one of the staff to visit us next year and conduct some training for our staff. And hopefully they intend to bring down some other monitors. We are very grateful to them because they have given us references to most of the sensors manufacturers. And so the manufacturers, once they know AQ Spec is affiliated with us, have readily give out their sensors because they have given us that reference. We are grateful to the EPA of Ghana. They have been our partners for quite a long time. We've been working together on so many other projects, and we still continue to work on this. We continue to help to build up the competence of the staff as they recruit them every year. And then finally, to our funders, the Clean Air Fund. This would not have been possible without the funding from Clean Air Fund. So we are so grateful to them and thank them for continuing to mentor us and continuing to fund this project. I think that's my last slide. The next one. So thank you very much. This is our story. And I must mention that we are still young. We're not a year old yet. We just started. Hopefully by sometime March or so, you will get our first reports hitting the website. And we are grateful to the manufacturers who are also present here. We're so happy that you readily send us your sensors and you have done other further engagement to see how we can do further collaborations. Thank you.
So Adrian should be in the Zoom call. So if we can put Adrian up here and allow him to share his screen, I think that would be great.
Yeah, good afternoon to you all. Sorry for the inability of the mayor to be present at this function to give the welcome address. Due to other equal important official engagements, she has asked me to represent her. She has asked me to represent her at this function. As you all know, by now, the introductions has already been done. So I have to introduce myself other than my name is Douglas Annoful, the Metro Coordinating Director. Good afternoon to you all once again. I'm reading the mayor's welcome address directly as she had wanted to do it. I'm pleased to be here and to welcome you to the city of Accra and to this August program. That is the Air Sensors International Community Ghana Conference. You are all warmly welcome to a city that has begun multiple activities to control the quality of the air we breathe on behalf of the Accra Metropolitan Assembly. In the past couple of months, the city and its climate and environmental management partners have worked to install over 50 air quality monitoring equipment in strategic locations around the metropolis. Ladies and gentlemen, these are the initial steps to understand the level of air pollution we are dealing with as a city. In accordance with international standards, Accra has committed itself to monitoring and reporting on the quality of air its citizens breathe on major global reporting platforms. Providing information and data on air quality is important to bringing awareness to our people. Air quality information and data are also necessary to facilitate the needed precautions and protecting and saving lives by taking action to improve the quality of air we breathe. Invited guests, ladies and gentlemen, we all know the health havoc air pollution wreaks, contributing to about 11% of the global mortality rate. This is a concern for the city, and I believe it's a matter of concern to us all gathered here too. I want to use this opportunity to thank the United States Embassy and Clean Air Fund in Accra for making real data from installed air quality monitoring equipment in the city. I want to encourage all our partners to emulate these examples to provide the actual data, since this will facilitate better decision-making and planning. Invited guests, again, Accra is a member of the C40 Cities Climate Leadership Group, as you may be aware, from which we have committed to leading the charge to show the needed pathways to reduce emissions in achieving a sustainable urban environment. The city has signed itself to an air quality declaration initiative to facilitate a comprehensive policy direction in dealing with air pollution. As part of impending global technological changes in the waste, transport, and energy sectors, Accra is also preparing to adapt and implement the principles of a just transition for all actors of our economy. The end result of this just transition process will be to equip our circular economy with the supporting infrastructure to continue to be green and sustainable. I will encourage all participants at this function to contribute to the discussions on air quality, on improving air quality, and on learning how to effectively use air quality sensors and the data that will help us effect the necessary policy change and trigger actions to reduce air pollution. Distinguished ladies and gentlemen, kudos to the organizers, University of California, Davies, Air Quality Research Center, and to their partners, Air Clean Fund, for a good job done. On that note, I once again want to say that you are welcome to the City Hall, Accra Metropolitan Assembly, and for that matter, the City of Accra. I wish you all fruitful deliberations. Thank you.
All right, thank you once again to the mayor's office. We very much appreciate it. It's great to have your involvement here and have you here to observe our going on. So I think we'll still stick with the schedule change, if that's okay. We'll do Adrian since he looked ready right now, and then we'll come back to Nuria, and then we'll finish up with Brigitte. So if we could transfer to the Zoom.
Thank you, Mike. Thank you, everyone, for this opportunity to talk a bit about our work on sensor evaluation and to exchange with the other panelists. So to introduce myself, I'm Adrian Arfire. I'm part of the Metrology and Innovation Service at Airparif. For those of you who don't know Airparif, we're the regional observatory, so in the Parisian region. We are accredited to run the surveillance, the monitoring network, sorry. Surveillance has a bad connotation in English, but it's the word in French. So we run the monitoring network for the region. We are an independent association, which puts together the different stakeholders who have an interest in air quality. So the state, the local collectivities, the economic agents, and other associations that have a stakeholder in air quality. We have a diversified financing, which ensures our independence, and we take a transversal approach to the problems of air. So we look at outdoor air, indoor air, but also at climate and energy. And I'm going to talk to you particularly about the Microsensor Challenge, which is in itself an AIRLAB project. AIRLAB is the innovation accelerator at Airparif, which was launched in 2017. The idea behind it being to go further and faster in reducing pollution in our region by facilitating and coordinating innovation, putting together actors from civil society, from research, startups, small and very small enterprises, large businesses, and also institutional actors. I won't stay too much on this, try to keep it short and get to the actual discussion. So in terms of the challenge, our objectives and principles are to link the sensors and their use, which we represent through categories of use. I'll get back to that in another slide. We're trying to provide information on the most relevant sensor by category of use and to establish a technological state-of-the-art of this rapidly evolving field. And we strive to support innovation so that manufacturers also get the feedback that they need in order to improve their sensors. So what the challenge is, it is a periodic evaluation campaign in realistic conditions of commercially available microsensors. What it is not a certification tool. it is ruled by a set of rules and a protocol. So these are two documents that are available on the project website, which define the conditions for participating in the challenge, how the selection process goes, the testing and the ranking of sensors. It establishes intellectual property and data property rights, confidentiality, and the possibility for candidates to withdraw from the challenge. So this is the rules or the terms and conditions of the challenge. And then the challenge protocol presents in detail the actual methodology of evaluation. So the categories, the evaluation sites, the performance criteria, how we calculate them, how we weigh them in order to get an overall score, and what the deliverables should look like. So the results of the challenge. I spoke briefly about the categories of use. The way we look at sensor use cases, we divide them in three main families, depending on their environment of use. So we look at outdoor air quality, indoor air quality, and what we call citizen air. So here we put all the sensors that target applications which involve the sensor being carried by the user, so portable use cases. And then for each of these big domains, we look at monitoring applications that are for awareness raising. In the case of outdoor air, we look at vehicular applications where sensors are deployed on vehicles. For indoor air, we also have, apart from monitoring and awareness raising, we have air quality piloting inside buildings. So systems that are sensor systems that are supposed to be interfaced with actuators. And for citizen air, it's just two categories of use. It's for exposure estimation and again awareness raising. And as a function of the categories of use in which the sensor systems target, the scores that they'll get for the different criteria will be weighed differently. So we basically have more than 20 criteria grouped into 5 major classes. So we can call them macro criteria. These are accuracy, utility, usability, either portability or form factor for devices that are supposed to be mobile, and cost. Depending on the use, a sensor that's targeting outdoor air monitoring applications, it will be expected to have a higher accuracy. So we'll put a bigger emphasis on the accuracy score than on the cost score, while for awareness raising applications, we'll put a bigger score on the cost aspect and a smaller weight on accuracy. So in this aspect, the challenge is quite unique because we're trying to look at the sensor system in a holistic manner. We're looking at the data quality aspects, but we're also trying to give some information to potential users in terms of what the user experience will be like. So when they're trying to deploy a sensor, to get an idea of whether it will be easy to operate or not, and of course also the cost aspect. All right, so I won't go into the details of the protocol. You can go and check that out on the website. I would like to give you an overview of how the challenge has evolved in time. So we're currently coming close to the end of our 4th edition, so the challenge 2023. The first challenge was in 2018. It's the same year as the first ASIC conference. We quickly after that had a second edition in 2019, but then realized that, well, the actual cycle of preparing and running the challenge really requires us to do a campaign every 2 years, especially since also the volume of sensors that we're testing has grown almost in every edition, except for the current one. So you can see that also the registrations, so the number of sensors that different types of sensors that were registered by the different companies has generally grown, but also the international profile, so the non-French fraction of the registrations has grown every year, with every edition. Sorry, we had a stagnation in terms of registration this year. This, from the feedback we've got from previous edition participants, was at least in part due to supply chain issues that were still affecting the market in the beginning of the year. So some of our long-time participants weren't able to deliver the sensors. So they either told us from the start that they couldn't register. In some cases, they registered, but then they had to withdraw. So the market was still under quite a bit of strain, like most of the electronics market was still at the beginning of this year. Yeah, this is another slide showing you a bit with more detail the evolution in terms of international profile. So you can see that the fraction of French solutions has decreased, although still remaining the biggest part. But we're diversifying. It's still very much an European challenge. Most of manufacturers are still based in Europe, and we're trying to reach out more to manufacturers from other continents. It's getting better, but it's still quite European. In terms of submission distributions, here these graphs are only for the current edition. Generally, we get a lot more solutions that target either outdoor air or indoor air in static conditions, with a minority of products targeting mobile applications. In this edition, a big novelty for this edition is that we've added a second outdoor air static site, which is outside of France. It was in Bangkok, in Thailand, and we were really encouraging candidates to send their sensors to both deployment sites so that we can learn more about the differences in performance for the same sensors when they are exposed in different conditions in terms of climate, but also in terms of emission sources and general pollution concentration levels. Then on the right side of this slide, you can see a bit what are the most popular pollutants that are targeted by these solutions, generally for outdoor air static conditions. We're looking at different fractions of PM concentrations, NO2 and ozone. More and more sensor systems are targeting or are providing particle numbers as well as mass concentration. This was not the case a few years ago, but it's becoming more and more popular. For vehicular, it's mostly PM, and in terms of indoor air, it's again PM with CO2, of course, and VOCs being targeted very often. And for citizen air, the most often it's just PM. In terms of evaluation settings, this year we continued the collaboration with our colleagues from the similar association in the Hauts-de-France region. So this is Northern France. So it's the regional observatory from Northern France, at Hauts-de-France, who put at the challenge disposal one of their monitoring stations, and also were very much involved in deploying and managing this deployment. Then we worked with our partners from Bangkok, the Asian Institute of Technology, the National Institute of Metrology in Thailand, and also the BMA, so the Bangkok Metropolitan Administration, sorry, to build a deployment in Bangkok. We were hoping to get a reference station. Unfortunately, in the end, this was not available by the time we needed to start the campaign. So what we did was to send an Airparif mission with our own reference analyzers, and we built a station from scratch on the rooftop of the Alliance Française building in Thailand. So you can see the reference station that our colleagues built, and the deployment of the sensors, which are right next to it. In terms of indoor air, we've starting from this year, we've built a new extension to our meteorology laboratory, which is dedicated for this kind of tests, not only for the challenge, but generally for innovative sensing systems. And you can see a two-sided picture, one with the sensors on one side and the reference material on the other side. And then for the mobile applications, for the outdoor vehicular category, we equip one of Airparif's vehicles with the reference and the sensors that are typically mounted on the roof of the vehicle. And we have a protocol for doing runs around the region to gather data. And for citizen air, we typically have a backpack with a reference for particles, and we attach the sensors to it. And again, we have a protocol for how to expose the sensors during a typical commute. The results since the last edition have been presented in an interactive way for a web platform. You can see the link on this page for the previous edition results. The results for the current editions are not out yet, but we plan to have a similar platform, but of course improved. So what this platform allows you to do is to search for sensors depending on your targeted application. So you can filter by categories of use, you can filter by the pollutants that are targeted by the sensor systems, and then you can order them depending on different criteria that are important to you. Then once you find the sensor you're interested in, you go to the reports, you click on the other page where you have the listing, you click on the one you're interested in, then you move to the reports tab, and you get either a compact report, a very basic report, or a detailed report, giving you more information on the performance depending on the different criteria. And you also can compare two sensors side by side in case you're you're not sure which one to choose. For the current edition, we are having the closing event on November 23rd. It will be a hybrid event. Well, no, actually, it will be in person. It will not be hybrid. Sorry, but it will be on 2 sites at the Alliance Française building headquarters in Bangkok in the afternoon, and at the same time in the morning at the Airparif headquarters in Paris. So we invite all of you who are interested in the results to join us for this event. At this time, we'll also release the results, and after this, the current iteration of the challenge will be done. We'll be looking forward to a new edition. I cannot go into the details of what we're planning next because, of course, these are all very preliminary, but we would very much like to continue this approach of multiple sites that are tested within one iteration of the challenge, maybe even more than 2. So, I look forward to discussing opportunities also with the panelists of further collaboration between our different evaluation initiatives. Thank you.
Great, thank you, Adrian. Let's give a round of applause. All right, so if you can hang on for a few more minutes till the question and answer session, that'd be great. Otherwise, next we have Dr. Nuria Castell.
So I would take the time just to say, like, again, my name is Nuria. I work at NILU in Norway. There we also are testing sensors both in the laboratory where we have the facilities and also on the field against reference stations. But mostly of what we aim to do, here it comes. It's also like how to test sensors where they are not against a reference monitor, where we put them already in the city where they are deployed. How can we know the quality? Okay. So this is a belief we have in our group, is that the uptake of sensor technology in science, community monitoring, and policy has the potential to significantly contribute to tackling societal challenges as air pollution. So we believe that there are like 3 main things that sensor technology can contribute to. One is filling in current gaps in air quality observations, especially in particulate matter, the fine particulate matter, PM2.5. Also, sensors can help us to complement other in situ and satellite observation systems at both at local, national, and also at global level. And they can also increase data governance by allowing local communities to monitor their environment. So this is some examples on how filling current gaps in air quality data. And here in parentheses, you have open air quality data, because what is happening right now is a lot of the data is still in silos, in databases that are isolated from each other. So you see here, and you saw this picture before, where you have good coverage, you say in Europe, and this is an example, this is Spain. What happens when we start zooming in? We see, okay, that we have good coverage along the coast, in the capital, in the center, but still most of the regions are not covered. They don't have data. And if you still zoom in more, I don't know what's happening, it's go automatic, but it's okay when we manage. If you zoom more, you still don't have more data in many neighborhoods. So we have the sensor systems we are working with, statics you can mount, also like mobile sensors, for example, in the bikes, and also this kind of do-it-yourself sensors, like open sensors, open hardware, where people can mount their sensors. This is an example of Norway, a city, Kristiansand. There's only 3 official monitoring stations. A lot of their neighborhoods are uncovered. We work with the communities there installing their sensors, and we got a lot of more data and also bikes going around. And we were using this data to create high resolution air quality maps. We discovered also that even in Norway, we had many neighborhoods that are using wood burning for household heating, with also like high levels of air pollution. And this data is then made available for both the citizens, the policymakers, and scientists. So data that is collected by citizens using sensors, it's of great use. And data governance, last but not least, is also like this community monitoring. This is an example I took from AfriqAir, where they were using their sensors. And this is an example in Gambia, where there you can see there's only some monitors there in the coast, there's nothing else. And there we have one organization that has installed a sensor in their facilities, providing data that is useful. But if we want this data to be really taken up, to be useful, to help us to tackle these societal challenges, we need to have known data quality. It's important that the data, we know what are the purpose that we can use the data. Listen that I'm not saying data of good quality. I'm saying data of known quality, because there is no data of, well, it needs to be random for not being any purpose. Any data can have some purpose, have some use, but we need to know how we can use it. Also, this lack of interoperability and common semantics. Currently, a lot of data is stored in silos. Means like there are many manufacturers here and there using their data, collecting data, communities using data, collecting data. But if we don't know, if we don't have this data in a common way, in a standardized way, we cannot use it in a global way. And that is something we need to do. Also, there's low citizen participation among the more vulnerable and marginalized populations. That reinforces this inequality on the data coverage, because we might have data in some neighborhoods, but we still don't have the data in another neighborhood that might be where the vulnerable populations are living. So we don't have a good overview until we have almost every single point covered. So we need to bring them along and help us to monitor their environment. Just like a little bit of like what the European Union is doing, there are some steps on the Air Quality Directive. There is like some steps on the European Committee for Standardization, setting up some rules on how we can test sensors and how to build facilities for testing sensors. And the European Air Quality Directive is now also like in the new revision is considering sensors as a way of giving us data. That's good. That's very good, but it's still not all what we can do, because they are not working with the communities. So this is a project I'm coordinating in Europe. It's called CityOps. It's just kicked out now. And here we will be working with both the social dimensions, like bringing all the communities and stakeholder engagement, tackling the participation dynamics, increasing trust, and also the technical dimensions, that is like known data quality, interoperability. We aim to have, at the end of the project, a knowledge platform, an open knowledge platform that people can use to build their own citizen observatories for air quality. And we will be testing this in Europe with about 85 cities. And we will love also to be in contact with many of you to make this also like not only European, but also global. And a little bit more local on what we do in NILU. This is some examples of like what we see today in Afri-SET. That's some of the examples we have in some cities in Norway. We are testing sensors. And we have also built this agnostic data platform where we can gather data from different types of manufacturers and also apply data quality and correction, data simulation with, for example, air quality models, and they plus the sensors, or satellite data plus sensors to get us these high resolution air quality maps, and also data visualization with dashboards. That's maybe the more non-creative way of visualizing the data, but I was also like talking with Kyla. We are also working with how to bring communities in building art and other more ways of visualizing the data. So looking forward for your talk. And here also, okay. how we do, like, still, like, obviously, money is scarce, so we cannot have sensors everywhere. So we have also created a little bit of how can we optimize the location of the sensors in our cities, considering, for example, what will be like the average concentration, like we want to monitor where the concentrations are higher. Also the spatial variability that we cover, what we were saying, like not only one neighborhood, but a lot of neighborhoods with different sources of pollution, but also we want to monitor where the people is, right? So that will help us to say how to optimize our resources and still get a very good picture of the air quality. And this is also like just some examples. This how we have been using sensors also with community monitoring and citizen science. And this is also like some pictures, like helping, like the reference stations were not getting all the variability, and we get to know like some neighborhoods there where air pollution is really, really high compared to what the station was saying. Like also get to know like what is like the environmental factors that are affecting more the pollution, and also like then also like how to calibrate mobile sensors without having them against a reference station. So that's some of the things we're working currently. So some take-home messages from this. Local sensors can really fill up current gaps in air pollution data, but we need to know what's the quality. And then they can contribute to these in situ observation systems and complement other systems, but we need to then have more interoperability between databases. And also like citizen observations play a crucial role in filling this gap of data on air quality. So it's nice to bring them on board. It's helpful for both of us. And that's all from my side. So thank you very much.
All right. Thank you, Nuria, once again. Last speaker for this session, and then we will transition over to sort of the roundtable and discussion, is Dr. Brigitte Language. Yes.
Thanks, Mike. Thank you very much for inviting me to be here. I think a lot of what I was going to say has already been covered by the three panelists that have gone before me. So I'm not going to show you a presentation or anything. I'm just going to talk a bit about our experience in South Africa and our current direction regarding low-cost sensors and the use of low-cost sensors. I myself work at the Northwest University within the Unit for Environmental Sciences and Management, within the sub-program of Climate Change, Air Quality and Impacts. I'm a senior lecturer there as well as a researcher. So my focus in research is mainly on air quality and the ground-based measurements thereof. So that ranges from reference grade instruments all the way to using various low-cost sensors as well. Within our group, we focus a lot on both ambient air quality measurements. We do have a few reference stations of our own, which are mobile, as well as centered at one of our campuses in the Vanderbijlbok region of South Africa, which is a highly polluted area with power stations, industry, residential combustion, a lot of traffic. And at this station, we basically use this as our field intercomparison station, whereby anybody who's interested can send us their reference or their low-cost sensors or medium-cost sensors that they want to test against the reference station. And this is where we would typically do that intercomparison for them. So this came about probably around 2.5 years ago with the collaboration of the University of Leicester in the UK, where they ran a project called Leap Epi, where they wanted to leverage low-cost sensors for epidemiology studies, so monitoring both indoor and ambient air quality in low-income residential communities in South Africa that are prone to residential combustion, whether that is wood or coal. And in the study, we started with, I think, like 3 different types of sensors, and we ended up doing an intercomparison between 28 different sensors in total from 11 different manufacturers. So that was quite an interesting field experiment. So the main thing that I think that has not been touched on in its entirety is there are so many low-cost sensor manufacturers currently, and all of them do not have the same policies as mentioned and data policies, and also not data transparency in the full data cycle. So you would receive data from a platform which you actually have no idea what has happened to that data. And some users don't think of that when they actually get to using the data. So they might be working on data that has been changed to fit a specific representation of what they think the air quality should be. And this is something that we have experienced before, and also that some of our suppliers in South Africa who would supply low-cost sensors to the community have also had this issue with suppliers, that the supply them the instruments that have been tested and are controlled, but when asked about the data and how the data was corrected, you get no response. So I think for us in the science community and people who are considered to be end users, thinking about how we use these sensors, whether that is for specific projects, looking at residential combustion, traffic emissions, biomass burning emissions, for instance. For us as a science community, it's very important to have that data clarity and be able to access that full data transparency cycle to know what we're actually working with. Yes, low-cost sensors are very useful, but we need to be sure about what we're actually interpreting from that. I will be here the whole week, so if you have any questions on ground-based monitoring, use of these sensors in an actual, as an end user, the usability and so forth, I'm here to discuss that whenever you want to. Thank you very much.
So we've heard from 4 great presenters, all talking about sort of how they're doing things and in this sort of sensor evaluation space. From vastly different areas, right? We have 2 in Africa and 2 in Europe. So for this next section of this session, we're just going to kind of open it up. If anyone has any questions that for any specific speaker or for the speakers in general, now would be a good time. If you do, raise your hand. We'll come to you with a mic. And yeah, sure. Please do say your name and maybe affiliation as well.
Okay, thank you. My name is Alex from Kampala City. I direct my question to the sensor evaluation that we just saw at the Ghana University. And my issue is related to sustainability. While it's doing great work, you seem to be 100% funded. You're doing good work. This is supposed to be ongoing. It's not something that ends because many sensors come on the market. Even those you've already tested may still need to be, retested and corrocated for deployment. But maybe it would have come in the next talk. What are the plans for sustaining, assuming there's no funding? Those reference grade things are very expensive to maintain.
Yeah, thank you, Alex, for your question. And I think that is, we listed as our 3rd main objective is to sustain this center. And you agree with me in that it is quite a humongous tax because for now we have Clean Air Fund, but later when Clean Air Fund is not there, how do we sustain this? And so what we are looking at is that trying to build other partnerships, around the center as we have. We think that if we are able to come up with some very good evaluation reports, we think that manufacturers would want to come back because every time they come up with a newer version of their sensors, they will want it to also be tested. And so perhaps going forward, we may have to put a value to the evaluation, as I mean, it's done in some of the other centers. And then also we think that if we start adding some other value to this, some of them may want us to go a bit more than the basic evaluation, maybe using the machine learning algorithms to help them correct the, what comes out of the sensor, the data. So it is a big thing that keeps us awake, how to sustain this. And we hope that we'll get some help in the meantime. But we're building partnerships with other sensor evaluators from the Europe and America, and I think they will help us to understand how they were able to sustain, and we will learn from them. But it is something that keeps us awake, thinking how to sustain this. We don't want it to be just after the period with Clean Air Fund, then there's the center collapse. We also are in partnership with the Ghana EPA, because they also rely on the reference monitors. We are trying to work along with them, with the Ghana Meteorological Agency, to see how we can develop forecasting and regular updates. And we think that if we're able to package that, we could get some sponsorship to be able to encourage daily forecasts of air quality in the city. Thank you.
I think from our point of view in South Africa, the sustainability and funding is always an issue. I think in general, getting funding for air quality related aspects is difficult. So within our group, we don't necessarily see that as a mainstream activity. So we tend to focus on instruments that do come up that people want to use in our country. And then they would ask us to do a specific test on those, so they know at least what they are working with regard to implementing those specific instrumentation within their given project, whether that's epidemiology, indoor monitoring, ambient. So I think from our side, it's not necessarily the main source of income or having to sustain that specifically. But what does help us is the fact that we do have our own reference stations, and those are generally maintained within our already existing budgets. So it's just then adding that additional cost of getting those low-cost sensors deployed and doing the general aspects that relate to that maintenance, et cetera. That's about it.
So one thing that's different for the challenge compared to other evaluation hubs, which are really permanent, is that we are semi-permanent in the sense that we are running the challenge as a periodic event, and we have this type of fundraising for each edition. And with each, well, we do have some partners that have been there almost from the beginning, like the ADEM, which is the Agency for Environmental Transition in France, or the AFD. So these are big funding agencies for development in France. This year, it was, for us also, it was the Clean Air Fund that helped us get the challenge outside of France in terms of deployment. But it's always a tricky aspect. Like I said, the way we do this kind of fundraising every time we're building up a new challenge. It's a matter of building partnerships that can last from one iteration to another, but for every iteration we also need to get some specific funding. There's no permanent funding, that's for sure.
So I think we have two questions here lined up.
Thank you for the lectures delivered. I'm Abulude from Nigeria. Now, the issue of collocation, do you collocate for individuals too? Because you have been talking of manufacturers. Like me, I have sensors, which I do use for myself, but I am not sure if it is accurate or precise again. So for me to continue with what I'm doing, I think I need to collocate for it to continue, working. So my question is it for individuals or manufacturers you collocate for? And if for individuals, what are the requirements one will fulfill before this can be done for the individual? Thank you.
Well, I can say something about what we do. Before, I think like it's important to know that it's like a big difference between the global north and the global south, and the way we do the collocations. And the big difference here, and my colleague said, Brigitte, like we have funds for maintaining our reference monitoring stations, and that's a big chunk of money. In the case of Norway, it comes from the government. They are maintaining these stations. That means that the reference equipment against you are testing your sensors is working well. Well, in many cases in the global south, what is happening is that you get some money to establish it, but then you don't get money to continuing. And then this reference monitoring against you are testing the sensors might not be as accurate as necessary. You don't know it. Okay, so then this is something that needs to be solved. And this is a big difference on testing. And second, like when you're saying like for individuals, that's a very good question. And also like even in the north, there is not capacity for testing for all individuals that want to monitor sensors, right? Because they are very different. So one way that we are working, because we also work with communities and it's impossible to test every single sensor. What we do is like try to work on algorithms that can assess the quality of the sensor while it is located in their place. So like inside calibration or inside testing is not as accurate as collocation, but it does already give us an indication on the data quality. So that's the way we work there.
Okay, so for now, we would, encourage, people who want to have their sensors calibrated to bring them over, and then we can help them calibrate it. Because what we have realized over the period is that if these sensors are not calibrated, they tend to, give a wrong indication as to what is the quality of air where they are being used. And then, all of a sudden you see a community has risen up and said that, hey, this community is so polluted, and they can, stage demonstrations and those other stuff. And then the burden would be to go to the regulators, which is the Environment Protection Agency of Ghana. And because we work along with them, they will also bring those sensors to the center for us to test, so that they will be able to give whosoever is complaining about the issue of pollutions, what it is. So at our center, we open it up. We are even encouraging student groups to start, as Nuria said, start developing their own sensors, and then come and see how, where it co-locates with the reference monitors, because we want to encourage a lot of use of, this is all the Internet of Things. So if they have access to the different components and they can build a sensors, I think we would encourage them to see how well these sensors are working. And then I think they will take it off from there. So for now, we are open to individuals. But what we do is that on our website, we would publish reports from the manufacturers. And we don't rank them, we just give the report. But for individual, you come, we do your collocation, and then prepare a correction factor for you, and then you can take it and use it. Yeah.
So for us, we will help anybody who comes and asks. So our air quality community in South Africa is very, very small in comparison to maybe other countries. So we tend to know a lot of people who are involved in different aspects of air quality research. And in that case, a lot of the other researchers might not have access to reference grade instruments and facility as we do. And in that cases, we would just enter into an MOU with those researchers. Because we are a university, we have to have those in place. But other than that, we are willing to help anybody who has an interest and can sign an MOU and be involved in that, then it's fine. So we generally don't show anybody away. So as long as you have an interest in it and you do want your sensors to be accurate and understand your sensors better, then we're all for that.
Just like a clarification, we also don't throw anyone away, but with working with communities, I say like we are working about like with 85 cities, more than 100 persons in the city. It's impossible to have everyone, you know, like collocate, and also some of the communities live in areas where there's no reference station and they are not willing to come, and we don't have budget to go to there. So that's because it's so important to know the quality. You know, it's important also like to develop not only in collocation algorithms, but also to work with in situ collocation. You know, that's because it's very important that to be sustainable in the future.
Great. Just want to check with Adrian if he has an answer to this.
I share very much the position of Nuria. We have a limited bandwidth, so we cannot really help everybody out individually. We have different partnerships with researchers, and for the general public, what we typically do, we have projects of sensibilization in which we try to pass some messages as to how to best use the sensors. So what use cases they are good for, how to have a critical approach to reading the data, so that they understand the limitations of these platforms, especially if they're not calibrated and if there's no infrastructure that allows you to regularly calibrate it, so that they understand that well, it's a bit in the line of what Nuria was talking about, knowing the quality of your data. It's not a matter of good or bad data. It's a matter of understanding how you can use the data. So even if you have a sensor that's not calibrated, having some dynamic on that sensor, if you are if you have been trained a little bit as to how to interpret it, you can make some use of it. It can help you understand that, yes, in this situation it's probably because the targeted pollutant is varying, or maybe it's because I left it out in the sun and it was under direct sunlight, and the temperature has an impact, the humidity has an impact. It depends on the technology. So we're trying to, also have a pedagogical approach, especially towards the general public, so that they have this way of having a critical approach to the use of sensors.
Great, thanks. So actually a pretty big division between Global North and Global South there. So next question. Name and affiliation.
Okay. Thank you very much. My name is Rose Salani, a Quality Monitoring Research Group, University of Lagos, Nigeria. I'm trying to combine what the question that Alex asked with his own. So sustainability of the reference monitor is really very key. And with those in the global north that have enough funds to maintain the air quality monitor, I think it's easier to co-locate for individuals and for the manufacturers. But for us in the global south, that we don't have fundings to sustain the reference monitors, I want to know if we can add some charges to some cost, just a bit, to the individuals that come to co-locate, apart from the support we have from the manufacturers. Because I think the best way is to add some charges to the individuals. I believe that's what he was trying to ask, that what are the requirements for co-location for those individuals that do not have reference monitors. I don't know what you want to say about that. Thank you.
Okay, so for now, we have funding. So as I said, this is quite a new project. And so for now, we still have the support of Clean Air Fund, but maybe in the next year or two, I think we will take a decision as to, what to do to, ensure that we have the reference monitor, the maintenance and other costs, that comes with it. As I said, the facility is also shared with the government. So we are also in touch with the Ghana EPA and to see how they can have budgetary allocation to ensure that we don't run out of supplies. So we know for now the EP is also helping to, maintain the reference monitors. So we are partnering with them, and going forward, we think that, as I said earlier, we will look out for other partnerships because the funding from government can only reach a certain level. And so if we need to have this sustained, then we also need to look for other partnership. As Clean Air came in, we'll look for other to sustain it. But I think it's still discussion points, and we are open for suggestions. I think if you want to give us some funds, we are available. Just see us, and we would readily accept your funding. Thank you.
So I think the type of institution that is going to do your co-location for you or compare your instruments has a big role in that. So it's going to depend on the institution that is doing the co-location for you. For instance, if it's a university, they might have the resources, so they might just charge you for the services that they provide in doing the actual co-location or intercomparison, or whether it could maybe be a proposed collaboration whereby you might not be charged anything. So I think it depends on the situation for what you need the co-location to be done for. So I think that's going to play a big role. For instance, I work with the university, so I think it might be different for other companies who aren't affiliated with universities, for instance. So I think that you might have to look into that to be more clear on what it might cost you to, as an individual, to get your sensors calibrated or co-located.
Yeah, and if I may just add, we've already started some of these talks. I mean, we have a local company that have started talking with us. They want us to do other works for them in terms of evaluation of other types of sensors. And so we are in talks to see if they can also provide some level of funding for the type of work that they want us to do. So it's an ongoing discussion. Thank you.
Well, I might have a tip for how you could, at the same time, keep evaluations open. And so the way we do it with the challenge is that we don't necessarily share the complete data with everybody. We share the reference and the sensor data within the consortium, and the consortium partners, they most of them are paying partners, at least a nominal sum. So there are different models as to how to finance this kind of enterprise. So you might choose to have the interested user pay a fee, or the manufacturer pay a fee, or have a group of partners that are interested in having access to the data for research. For us, it's typically for research, and then you have them pay a fee. But yeah, somebody needs to pay for already. If it's not for maintaining the equipment, it's for the work that needs to be done for the evaluations.
Great, thanks. Thank you. I'm Kwabena Fusuamankwa from CK Tadem University in Upper East of Ghana. I'm conducting a lot of studies within the indoor microenvironment of vehicles. Now, the third speaker talked about some studies she had conducted with her team, and I wanted to know how she went about validating her data in terms of the mobile environment, if you did anything within a mobile microenvironment, because of the frequent changing of parameters that can affect air quality in such an environment. Thank you.
So we typically focus more on the indoor and ambient environments. But for the mobile environment, that is true what you're saying. There is a continuous change in your environmental conditions, which definitely will impact your sensors. So I would refer to somebody who's actually done validations for mobile sources. Okay.
Yeah, we do two things. One is like the validation in the laboratory, and there we try to replicate like the effect of the air. Okay, like with a sensor, like not having the sensor static, but a sensor will be moving. That's the validation in the lab. But also, like, we focus a lot on the validation on the ground. And then what we have developed is some machine learning algorithms. And then what we have is like we see when one sensor is passing nearby a reference station, and then we use this data to create and evaluate the quality of the sensor and also calibrate it. And then when one sensor that has been recently calibrated and is passing to another sensor that has not been calibrated and is moving, so we try to do that in a kind of like real time. So we have published a paper that I can share about that. But it's difficult. It's not like it's yeah, because it's also like minute data, right? Like, so you need to have like data that is very often, and with the static ones, you can average for 1 hour, and then already takes out a lot of the noise of the data. But you cannot do that when you're working with personal exposure. So the data tends to be of less quality, but still, if you calibrate it, it's still like usable for many purposes. Yeah.
Again, I need to align with Nuria. The subject of there's multiple names for it, but like rendezvous calibration is one of them. It's a difficult subject. We had in the challenge, we don't typically we don't look at calibration algorithms. We evaluate the sensors as they receive, but we had projects in the past trying to achieve that. It's difficult. It's a difficult problem. It's also difficult as a function of the pollutant you're targeting, because you have technologies that are fast reacting, like optical technologies for particulate matter, and already there it's difficult to when you're looking at a small rendezvous to so a small meeting between the sensors to have enough data statistically to apply a calibration, and then we're thinking of electrochemical sensors, which are slow reacting. The problem is almost impossible to solve, at least with passive exposure of the sensors. So to me, that's more of a research question. It's an interesting one, but there's a lot of work to be done in research to deal with it.
Maybe I can just add a point, like also like one of the things we do to try to make more sense of the data of the mobile is that we account and do averages with the passages of the vehicle, like the bicycle or the vehicle that has the sensor in the same street, right? So like when the bike, for example, like we do like, let's say like a yearly average, and then there's like one bike with a sensor has passed in this part of the street, let's say 50 times, right? Like, so then that is the way we are averaging. Instead of temporal averaging, we do this spatial averaging, and that helps us to take more quality out of the data and more understanding on how to map the spatial variability in the city. So that also might help.
Great, thanks.
Thank you. My name is Christiana from University of Cape Coast. This morning, I was very happy when I heard that University of Ghana, they have a reference sensor, because I've been coping throughout since the last 3 years for calibration of my low-cost sensor. So I'm interested in the sustainability of the sensor at University of Ghana for Dr. Allison for. So my suggestion, this one is a suggestion. I heard from you and this morning that you have a collaboration between you and EPA. And I know EPA, they deal with issues on air quality for the whole country. That is on every industry. Now, Ghana, we have a problem, and the problem is the gap between the scientific community and our industry. And I know this is one of the main area where the industry or the University of Ghana can collaborate with the industries to bridge that gap to also help. For instance, last 2 years, a friend of mine came all the way from Canada to measure air quality for one of the mining companies in the country. Meanwhile, your center could have or can do this to generate more funds to support and sustain the center. So I am encouraging the center to bridge that gap, maybe through training of more students, reaching out to them, and also, as you said, you are online. You can go to them and then sell the center to them. As I said, it was only this morning that I heard that you have a reference center. So let us sell the center more to the industry, the general public, and everyone. And also, I don't know what you'll be doing, or after this program, Ghana, we have policies, but we don't implement them.
So the implementation of the policies will help also the industry to make sure that they abide by the rules and regulations governing air quality, therefore patronizing the center more. So these are my few suggestions that I'm making. Thank you.
Yeah, Christiana, thanks a lot for the suggestions, and we'll take that on board. Thank you.
Thank you very much for the opportunity. I am a atmospheric scientist, and also, shall I say, a campaigner for public health and safety. Some few years ago, I was sent by the University of Cape Coast, my alma mater, to do some stakeholder engagement. And I was with 4 different ministers. And then they also directed me to their chief directors because they said they are politicians. They are not, experts. And when I was engaging with some of the experts, there was this gap that they were raising concern. They said they don't have, right now, when COVID kills someone, this person was killed by COVID, but they don't have data to point to the fact that this person died out of air pollution or water pollution. And that was the data I was looking for. I was working with an institution in the UK. And so I want to find out from this community, since this is a global forum, whether there's any modality, there's any way of finding out how many people are dying from air quality, poor air quality, and the constituents within the air, which of them are responsible for this number of deaths and for that number of deaths, because that is what normally scares the politician and the policymakers. From what I've gathered from them, they want to see empirical evidence. They will tell you our forefathers have been inhaling dust and smoke and all that, and they live long. And we are just talking science. They want empirical evidence to show that this number of people, died as a result of poor air quality. I think we have some of those figures globally, but locally, I'm not sure. Thank you.
You want to answer? Yeah, I think the question he said is for the community. I know that the Environmental Protection Agency of Ghana has done quite a lot of work along with the Ghana Health Service, supported by the World Bank and the WHO. I think they have a project, CCAC or so. And so they have been able to collect data. I think so far in the world, there's only one person who have had a certificate that said that they died from air pollution, and that was in the UK. The rest are all, those who are epidemiologists, they are able to go back and see your exposure and know that due to your exposure, you may have, contracted a particular disease, or perhaps due to where you live, it is prevalence of certain pollution that may cause certain diseases. I'm not a public health person, I'm a physicist, so I will leave that more for those who are in the area of public health, if you want to maybe throw more light on this. Yeah, thank you.
My name is Vikas Kumar. I am a student at IIT Bombay. Actually, we did a study last year where we compared how the performance of a sensor drifts within 2 years So we separated the data into 2 different tiers, and then we compared how they compare to the reference instrument. And we found out that it is not very much drifting in the second year compared to the first. I would like to know the opinion of speakers, because when we are saying that we have already calibrated a sensor using reference instrument, so in essence, we are saying that it acts as a reference instrument. So can we use that to calibrate other sensors so that it can reduce the load of people who are maybe doing calibrations? Or does the speakers have done such kind of work or have any such experience?
Yeah, that's a very good question, because currently I will say this varies a lot from sensor system to sensor system. So if you have tried this study for several years and you saw that sensor system was not drifting, it's valid for that specific sensor system, but it does not apply to all sensor systems. Another question was like, if you can use a validated or calibrated sensor to calibrate others. And here, like, although like the golden, we use this way of golden equipment. That means like one equipment that is calibrated and that can have better data, than other. And then you can use that to calibrate others. The most good way to saying is always use official or standard equipment, reference equipment, but not always is possible. And there's also some works done in UK about using this golden equipment, like to do this mobile calibration, like moving one sensor that is calibrated to other sensors around and then use that, instead of moving all the sensors to the reference station from time to time. And that has allowed to maintain a network of sensors for a longer period within budget. Because if you have a sensor of 100, 1,000, a network of sensors, you cannot, it's impossible to just move them every 3 months to check if they are still calibrated, right? So the use of these golden standards or golden equipment, it's a way of doing it, yeah.
Again, I agree with Nuria on the points she made. I would add also that sensor drift varies a lot depending on the sensor technology. That's so optical sensors tend to drift less. It's a matter of exposure, whether the optical parts are well protected from dust accumulation. So yeah, optical sensors, they can last for a long time. Electrochemical sensors, and I'm thinking in particular for the ones that are targeting NO2, they're a bit tricky because generally the technology is targeting both NO2 and ozone at the same time and adding a filter for ozone. That filter for ozone will deplete depending on exposure to ozone. So typically this type of sensors, depending on where they are deployed, they won't last that much, maybe 1 year. If it's a sunny area, after 1 year, I would check that they're still okay, that they're not measuring NO2 and ozone at the same time. Then, yeah, there are different ways of, there are this golden sensor nodes that you can move around. Then one thing that I really want to stress out, the fact that you're calibrating a sensor does not automatically make it equivalent to a reference, because you might reduce the distance, so the error, you might make it more true, but you're not necessarily getting rid of all the other artifacts. You're not necessarily making it a less noisy sensor. You're not necessarily making it less subject to cross sensitivities, or it being perturbated by temperature and humidity aspects, and particularly for particulate matter sensors, you're never really you always have the off event where you have particles of a different nature being imported from a different region. And if you have calibrated the sensor for over a certain period of time with typical particle nature, so in chemistry, for a certain site, your optical sensor has some assumptions as to what this composition is, which are implicit when you're doing the collocation. If you get this type of event where you have particles being imported from another area, your calibration won't work. So just a few things to keep in mind.
Yeah, thank you very much. I think I'm grateful that the coffee vendor couldn't come, so we could have a chance to ask our questions. Well, I'm Professor Ewana, University of Cross River State. I have some concerns about reference monitors and the idea of maintaining standard. Some of the monitors called reference monitors are made by different companies, and we have called them reference monitors. What standard do we have? Is there really a unified standard? Is there a standard somewhere where these same reference monitors are calibrated? Because we know as instruments are used, they degenerate with time. So what is the standard by which we can say these reference monitors are accurate? I speak as a physicist. If we say 1 meter, for instance, we have a standard somewhere that from time to time we go there and say, okay, let's compare what we have. That what we have there is still the same thing that we have here because of obvious changes that may occur. You know, the atmospheric conditions may affect, you know, those equipment and the use and all that. With time, they may depreciate. So my concern is serious in that direction. Please, can someone help?
I will try. So again, this drives a lot in the global north and the global south. So yes, we have standards, and that's what I was saying. Like we are very privileged because this is usually covered by governments and agencies, environmental agencies. They run the cost of that because it's very expensive to have an equipment test. So how it works, we do calibrate this reference equipment against gases. So we have the zero gas that should have no pollution, and then the equipment should measure zero. And then you have also like different concentrations of different pollutants, and that you as a cylinder, and you know the composition. It has also like in Norway, NILU is also like the reference laboratory for Norway, what means that in our institute, in our research institute, there's persons that go every month to visit the stations and check the equipment and do the changes and calibrate them against this zero span gas and against other gases and particles to ensure the equipment is still like has not drifted and has not is as well maintained and has any damage on it. And also like we do perform, because there are different manufacturers that also provide what is well called like reference instrumentation, and they need to be certified. So the instrument needs to pass also the standards that are drawn by the standard office in Europe. They need to pass that before selling the equipment. And then still we have on top of that, we have the Aquila network, that is the network of all reference laboratories in Europe. And then it's like every year or 2 years, they bring equipment to one place and collocate the reference equipment one against each other to test it. still we have seen like there are drifts, and this works very well for gases, but particulate matter, that's like there are not real-time equipment, they're only equivalent equipment, okay? The only standards for particulate matter is the gravimetric. That's the one that you have the position, and then you take it to the laboratory and you weigh the filter, or you analyze the filter. But for example, what we have seen with the equivalent reference equipment for particulate matter is that they have differences among themselves, even if they are two manufacturers to having reference equipment. So there's still like struggles also with the reference equipment, but yes, there are standards in place, but maintaining those standards is very expensive, and that's the thing we need to also like bring how to do that in the global south, because this is having well-maintained reference equipment is critical. It's critical to also to have the use of low-cost sensors. And this is something we need to get into the minds of the people of the funding mechanisms, that they fund the instruments, but they also need to provide some funds at least for some years until this facility can be working on its own. That's not easy. Provide some funds also to maintain the equipment. It's a necessary change. But yeah. Do you want to add something on that?
Yeah, just to add to what Nuria said. Yes, we also have standard operating procedures for our reference monitors that we use to calibrate them based on the procedures. And I think I'll take off from where she ended. Yes, approach a funder. They bring in the reference equivalent monitor, and then that's it. The rest is left with you to ensure that it works. And that was what happened in the case of these reference monitors that was brought in by the World Bank. And so how do we sustain them? How do we continue to keep them running? Otherwise, they get broken down, and then all the money put into building the infrastructure, bringing the equipment, is just sit there and it's never been used. And so that is why, as she said, funders should look at that aspect, at least to sustain the equipment over a couple of years to ensure that they keep running, and then we can now look at how to sustain them. I think there's another panel that is going to take place on Thursday, which will look at the issue of funding, because in this area, you find that, yes, we have funding, but sometimes the funding is just to procure air sensors or local sensors, not to look at the gravimetric sensors, which is the gold standard, as she said. Then even with gravimetric, you collect the filters. How do you analyze the filters? You need good microbalances. You need also to have a way of extracting the multi-element analysis, other X-ray fluorescence analysis, atomic absorption spectrometry. I mean, we need more into this. Yes, we are here for air sensors, but then there's other things that should support, the evaluations. So I think that it's good that we are discussing this, and then I think there's another panel that will discuss this in detail on Thursday to look at the funding of equipment for monitoring for lab. It's one thing to have a air sensor. It's another thing to have a reference monitor and to maintain that equivalent of reference monitors, as the professor said. So I think that it's good for this discussion, and I hope that by the time we close from here, we would maybe be sending out some signal as to how to get some of these funding. Most of it comes in grants, and these grants are time bound, So once the grant period is over, the project just go to sleep. But we don't want that to happen. We want to continue because these are equipments that can be used for more research, more teaching, building more capacity. And I think it's a good question that you raised. Thank you.
So I think from our side, we use pretty much the same approach as in Europe. I think most of our reference instruments come from either America or Europe. That's where they are manufactured. So we follow the manufacturer specifications regarding calibrations, etc. And similarly, within our reference network, we have trained technicians who do these calibrations on a monthly basis. We also tend to arrange inter-lab calibrations. For instance, we would, as the research group, would calibrate the same station as the South African Weather Service that maintains the network, the national network, and then we would do those intercomparisons or calibrations as well to just check each other to see that everybody's doing everything correctly. So I think another important thing to understand is that reference instruments still come with their own set of errors and uncertainties. But what we know about reference instruments is that the technology that they're based on, they've been studied for numerous years. We understand these uncertainties a lot more than we do understand low-cost sensors, for instance. So I think that's just where the difference comes in between understanding that these are reference instruments. They're not 100% correct either. They have their own uncertainties, but we understand those uncertainties much better.
Yeah, just the last one is that we try to, I mean, at our center, we are trying to put several different reference grade and see how they also, come close to each other. And then our reports will also mention the reference monitor that was used. So I think Nuria made mention of that even among themselves, the reference monitor, if you take a BAM 1020 and take a Teledyne, you will see that there's a bit of discrepancy when it comes to the data. Yeah.
This has been a great discussion. I know that there's still lots of hands up and a lot of people want to say things. It's also about 5 minutes until the next start of the next session. And I think people would really probably appreciate a break before we go into that session. So if you have questions, join the Zoom, put them in the chat there. They will be saved for perpetuity. We can discuss them in breaks. We can, write white papers and answer things there as well. So, all right, cool.